Morning, sir.
Hey, morning, buddy.
कैसे हो?
What a hunt, sun, fantastic.
चलो सही.
Good morning. Quick question to all of you guys. What is the multicast address? For any agent? जल्दी करो. And what is the protocol number? Not protocol number of product and EIGRP. ये है तुम्हारे. And सही बता दो बहुत है. मुझे पता है किसी ने प्रैक्टिस नहीं किया. I know very well. फिर भी बता दो. दिल को अच्छा लगेगा मेरे. क्या क्या 240 क्या किसका गलत है. 942229 एंड चलो एक तो सही हो गया. नेक्स्ट वन बताओ. पास कर गया तुम लोग. 15,000 रुपये. नेक्स्ट वन. अरे नेक्स्ट क्वेश्चन हो गया. मिल गया ये 1,000 रुपये. तेरे मस्त मस्त दो ना मेरे दिल का देखो. गूगल करो. साथ के सब गलत हो यार. पता कर यार. Everyone is incorrect. Everyone is incorrect. Every single person. मुझे पता है सबने गूगल किया है अभी कभी. फिर भी गलत हो. EIGRP 88. What 88? Complete. Tell me the complete one. What 88? हाँ तो ऐसा बोलो ना. IP प्रोटोकॉल नंबर 88. नेक्स्ट वन. रिप. गया. फेल. यूडीपी. अबे क्या यूडीपी निजाम. व्हाट यूडीपी 520. क्या यूडीपी. मैं क्या समझू. पोर्ट नंबर समझू. प्रोटोकॉल नंबर समझू. क्या समझू मैं इसको. तो टेल मी समथिंग लाइक दिस ना. मतलब थोड़ा सा तो मैच्योरिटी दिखा लो नेटवर्किंग में. मुझे पता है अपन के पास नहीं है बट नेटवर्किंग में है. ठीक है थोड़ा सा बी मैच्योर इन द नेटवर्किंग. Okay guys, so yesterday we have discussed about the hello packet, right? And this hello packet is used to form the neighborship to the UDP protocol number and port number. मुझे बता. मुझे क्या बता. तुम बता रहे हो या पूछ रहे हो. It uses the UDP protocol and port number is 520. It uses the UDP protocol and port number is 520. पूछ रहे हो बता रहे. मुझे खुद नहीं पता चल रहा. तुम. Hello packet is used to form the neighborship and maintain the neighborship, right? After forming the neighborship, what happened? Router keeps sending hello packet at every 5 seconds to form the neighborship. And yesterday we have seen that the hello packet will be sent on the 224.0.0 and right. This is the multicast address. Okay. And in this multicast address, there is no router ID, right? So not multicast, there is no RID in the hello packet. As compared to the, your OSPF, they do have a RID in the hello packet. So whatever the EIGRP neighborship criteria, it's not like that, take example, this is the guy over there, and this is the guy that's sitting on the A in the airport, and this is the B over there, and he's sitting on the airport, right? So what happened? A and B wants to communicate to each other. So what I first of all, B will introduce itself. Hey, this is B, right? And this guy will say, hello, this is A, right? Hello, this is A. It's not like that. After the exchanging the hello and hey, they will form the neighborship. No, it's not like that. For example, he said, hey, hello, I'm B, and hey, this is a B A over there, right? And after that, what? Will they form the neighborship? Will they start the communication? Will they start the exchanging any information? It's depend, right? It's depend. Depend in the sense of what? For example, this guy, right? This guy is belong from the China, and this guy is belong from the what? India. Now tell me, this guy knows the language, which language? Chinese, right? And this guy knows the Hindi language. Now, can they communicate? No. So what B is assuming, B is just making assumption. Okay, the A belongs to the India. So if I'm going to say that, hey, this is B, will they understand this message? No. So still what happened? Still router one can send the hello packet to the router number two, right? Router one can send the hello packet to the router number two. Hey, let's form the neighborship. But still router two cannot form the neighborship because router two maybe have some different rules over there. In this case, what happened? This guy A does not know Hindi, right? Or maybe they does not know English as well as. They only know the Chinese language, right? So they only understand the Chinese. So if this person will speak out in the Hindi or English, will they understand? No. If they don't understand, what happened? They will drop it. Same thing is happening on the router number 1 and 2 case. If the router 1 sends the hello packet, if the router number 2 is not understand that hello packet, they will drop the neighborship. Or not drop the neighborship, they will not form the neighborship. That's why it's calling, right? The one saying is that do friendship only who can understand you, right? Do friendship only who can. It's not like you can make a friendship with any person. You have to match the criteria, right? Before forming the friendship, what happened? You need to satisfy the criteria. The criteria could be anything, right? Maybe you must need to know that this guy should know the English language, then they can establish the neighborship. And if take example, if this know the English language, if both the person, so what this Chinese guy saying, hey, I only can communicate with the person who belongs to the different country, maybe the London. What he is belonging, Hindi, right? Indian, right? Can they form the neighborship? No, because this criteria is what? This Chinese person. Hey, I can only form the neighborship who belongs to the London. So in that case, what happened? They cannot form the neighborship. Still, they are matching something over there. They both know the English language and they both know the English language. They can understand the communications. But the criteria of this person is what? I can only form the neighborship with the London guy. Same thing is happening in the EIGRP case, guys. What happened before the router 1 is going to form the neighborship with the router number 2, right? When the router number 1 is going to form the neighborship with the router number 2, this is the 202 now. And we have take example, we have some one LAN network over there, /8. And we have another LAN network 2.0.0.0/8 over there. Now try to understand, if I'm going to configure the router EIGRP over there, 1, and I say the network 12.0, same thing. What happened? I'm going to configure the same person on the router number 2. What happened before the exchanging the route network? Before router 1 can exchange this information with the router number 2, they first establish, right, one neighborship and adjacency. They first establish the one neighborship and adjacency, right? But in this case, what happened? This both router, right, need to match the neighborship criteria. And what are the neighborship criteria we have? Both the router must belongs to same subnet. Another one, both the router must belongs to same AS number. Same subnet in the sense of what? This guy is also running with the 12.1. That's belong to this subnet, and this guy also belong to the this subnet. Then I can form the neighborship, right? But this is not only one. Other one is that if this guy is match, then I will say that okay, both the person is running with the same AS number. Which AS number? This guy. That's a group of router, right? If this guy is fine, what is the next thing I will have to look up over there? The K value should be matched. I'll explain you what is K value, but by default, K1 for bandwidth, K2 for what do we call over there? Load, K3 for delay, K4 we can call it reliability, K5 we can call as a MTU. These are actually a guys metric of EIGRP. If you remember that what RIP is using, only hope count, right, as a metric. And if I'm going to talk about the OSPF, is going to use only the cost over there, the link cost. But EIGRP and IGRP protocol, both this guy, right, is going to use all these properties of interface. All this is going to use the properties of interface. If you have a look over there, if you see show IP interface 0/0, show interface 0/0, these are the properties of interface. This is the interface, and these are the properties of interface. MTU bandwidth delay, reliability TX load, and RX load. Both are the same thing. Load can be two types. Either it can be a TX transmitting load and receiving load. Transmitting and receiving. And by default, what EIGRP is going to use? EIGRP is going to by default use this one, K1 or K3. That's how the value should be of K1 always should be 1, right? And K3 will be 1. And this guy is disabled, right? 0 means disabled. We'll go through that in a detail of this part. Don't worry about that. I'm just trying to explain you whatever the EIGRP neighborship criteria. K value should be matched. So it means that if this guy is both person in the same subnet, and if they both are running with the same AS number, the next thing is what? This guy is going to use the K1 or K3. This also need to use the K1 and K3. That is by default. That is by default, right? Should we use? What happened if this person is saying, hey, I would like to go for K4. I will never form the neighborship. Everything is same subnet, same AS number, K value is much mismatch is happening. If the K value mismatch, I will not form the neighborship. Once this part will be clear, right? If they have the same K values, what is the next thing I have to look up over there? IP protocol number 88 should be allowed in ACL if ACL is configured. So sometimes what happened, guys, on this particular interface, right? On this particular interface, maybe the ACL is configured, and that ACL, maybe the protocol number 88 is denied. So will they form the neighborship? Of course not, they will drop the neighborship, right? So your ACL, right, if the protocol is there, it should be allowed. Another one, if you have authentication, let me decrease the size. If you have a authentication enabled, then authentication should be match. Next one, the interface should not be passive. If you don't know the passive interface, let me know. Okay, and if you know, that's good. And the next one is that one more thing, boss. Yeah, I can do. Hold on time must not be lower than 100. If this thing is happening, you still form the neighborship. But flapping will happen. Flapping we can call is a bouncing. Flapping of neighbor will happen. And flapping of the neighbor will be what? Your packet loss. All those things, right? All these things should be one. And another one is that like that's the basic one, but again, still I'm right on this part because you know, many person like make a mistake in the interview. Interface should be up. That should be most important. If everything will be matched, then this two router is going to form the neighborship and adjacency. In EIGRP, just write down what this word line as well as in EIGRP, every daughter will form the neighborship and adjacency. But in OSPF, every daughter will form the neighborship, but adjacency only with DR and BDR. Like this one. Take example. I'll do one thing. I'll take a screenshot of this guy. That will be good. So 1 minute. All good. All good. This one. This one. This one. And the IP of this guy will be. The IP of this guy will be. And the IP of this guy will be. IP will be this guy. So this is the subnet 1.0/24, and let's do one thing. I'll copy and paste it. Okay. Wow. Great. 1 minute. Let me reduce the size. That's good. And now I hope I can have a space. Perfect. Okay. This is the example of EIGRP, and this is the example of OSPF. In EIGRP, what happened? In EIGRP, R1 will have a 4 neighbor and 4 adjacency. R5 also have the same thing. R2 also have the same thing. R3 also have the same thing. And R4 also have the same thing. 4 neighbor means what? Take example of R1 case. They have a neighborship adjacency with this person, this person, this person, and this person. Right? Same thing now, like this one. Like this, like this, like this, and like this. Now it's my turn. Like this, right? Like this, like this, like this. Now it's this turn. Like this, like this, like this, like this. Now our turn. Like this, like this, like this, and like this. Like a full mesh. In an OSPF case, what happened? Take example. This is my DR, and this is my BDR. Okay. This guy has a 4 neighborship and adjacency, right? This guy has a 4 neighborship adjacency. This guy will have, this is the DRO, right? R2, R3, R4 is behave like a DRO. This guy has a 2 neighborship, 4 neighborship and 2 adjacency. This guy has a 4 neighborship and 2 adjacency. And this guy has a 4 neighborship and 2 adjacency. Neighborship means what? A very simple language, if I may tell you. Take example, this is the one guy, and this is the another guy over there, right? So A and B. So what happened? A has some magazine, right? Try to understand this part. A has some magazine. And what happened? The B start the communication. Hello, this is B. Guys, pay attention over there. Hello, this is B. And A will also say, hello, this is A. In this case, what happened? Listen to me carefully. In this case, what happened? B has a knowledge about A, and A has a knowledge about B. That's it, nothing else. So neighborship means what? Neighborship means you just have a knowledge about your neighbor. Neighborship means what? You just have a knowledge about your neighbor. That's it. Now, if B wants, right? B, hey, I need your magazine, right? I need your magazine. So now what happened? A will give the magazine to the B. This magazine I'm talking about. This is called adjacency. In adjacency, what happened? Now the router, and see what happened. Now the router can exchange. Yeah. So in router one, if the router one found the neighborship adjacency with the R5, they can exchange the route with this guy as well as, and R1 has knowledge with R4. 5. Same thing, if R1 is going to form the neighborship with R2, they can extend the route to this guy. They can extend the route to this guy, and they can extend the route to this guy. And even if this guy has some information, they can extend the route with this guy. They can extend the route with this guy. They can extend the route with this guy, and they can extend the route with this guy directly. In EIGRP, but in OSPF case, what happened? R2 has an adjacency with whom? DR and BDR. So R2 can only exchange the route with the DR and BDR. It will not going to share this information to this person, not to this person. Can you see in this case, they are sharing this 2.0 information and to this guy as well as, this guy as well as, and this guy as well as R2. But in the OSPF, it's not sharing. They will first share the information to a DR, and now DR has a responsibility to share this information to the every person because DR is going to form the adjacency with every guy. We cannot say that it's doing the load balancing over there. It's not like it. What is the meaning of load balancing? They can share the load to the router, right? There's no, this is like a primary over there. If the DR is available, BDR has no role. So this is the amazing difference, right, between the EIGRP and OSPF. And you guys, adjacency is your logical connection between the router. Logical means what? We don't need to connect in a kind of physical connection. It's a logical, virtual connection. It's like a virtual connection. So the router in the EIGRP can form the neighborship and adjacency. So if you have a look over there, what I can do, I'm just going to take example of R1 and R2 right now. Do so IP interface brief, please. Yep. So this guy has a 101 IP addressing, and if you go back to the router number 2, this guy, they have a 102. Perfect. I'll just run the router EIGRP on network 0.0.0.0. 0.0 means what? You can advertise all the route, all the directly connected route. You can use this command for the practice purpose. Connected interface will enable in EIGRP. You can use this command, for the practice purpose, but not for in the production network, not in the examinations. For the time saving, I'm just citing, right? R1. See, they can form the neighborship. Can you see? At the same time, they are forming the neighborship. Have a look if you see. They are forming the neighborship and adjacency as well as neighbor and adjacency. So in EIGRP, every router can form the neighborship and every router can form the adjacency, but not in the OSPF. So do you know if this two router is forming a neighborship between this guy to this guy, do you know they will follow all this criteria, all this one. Take example, what I can do right now. I'm just going to Like, just pay attention, guys, over there. It's like, it's important. What I'm going to do on this particular interface, right? This particular interface is a part of which member right now? It's a 1.0 subnet, right? This guy is a member of 1.0 subnet. This guy. I'm going to make this as 2.0 and let's see what happens. Neighborship is down. And what error message I'm getting over there? Understand? Not in the common subnet. It means that he's saying that, hey, my router is not able to form the neighborship just because they are not belong to the common subnet. Subnet means what? Same network ID. They are not belong to the same network. Because now this guy is running with person 2.0 slash 24, and this guy is running with the what? Will they form the neighborship? No, they cannot form the neighborship. Now let's take example. What I can do right now on a R1, you see they are always running this system of massive, but they are not forming. So do we have a neighborship over there? No, I don't have a neighborship. Do show IP neighbor? I don't have a neighborship. What I can do now, let's make this guy IP address will be same subnet now. Done. So now they will form the neighborship. Good. They form the neighborship, right? Let's do one thing. By default, if you should do show IP protocol, what I told you that. I told you this guy, right now, this part. Where's that? Both the router, before forming the neighborship, both the router must belong to the same subnet. It means that if this router 1, understand this diagram over there. Zero slash zero. This interface 0/0. We can call this guy as a 12.1, and we can call this guy as a 12. They belong to the same subnet. Let me do one thing. Let's form the same one. Otherwise, we will get confused. This guy's a 101, and this guy's a 102. Right? And this guy's subnet is what? So right now they can form the neighborship because they belong to the same subnet, right? Same subnet. 101 is belong to the same subnet, and 102 is belong to the same subnet. What happened if I'm going to give this person, hey, your IP address is what? Not 101. Your IP address is now 2.1. Can they form the neighborship? No, they cannot form the neighborship because they are belong to the different domain. If first 24 bit same, they will form the neighborship. Yeah, we can say like this. Not first 24 bit. If I'm going to do the subnetting, then it's not like that. They belong to the same subnet. Question clear now. So in this case, now what happened? They will not form the neighborship because this guy has a what subnet? This guy has a subnet is 192.168. Like 2.0/24, and this guy is what? What is the next one? So now this guy is fine. Okay, they belong to the same subnet. What happened if you see the key values by default? By default, what R1 is using? K1. That's I told you that K1 is by default delay. Sorry, bandwidth. This one I'm talking about right now. K1 is bandwidth. By default, it's going to use, and K3, right? That's a metric of the EIGRP. If you see the K1 I'm going to use over there, or K3, 1. By default, you see this thing is disabled. I will explain you what is this. Don't worry about that. Okay. And if you go back to the router number 2 as well as do show IP protocol, can you have a look over there? This guy also going to use the K1 or K3. So right now, both this router, right? is going to use the same K values, K1 or K3, K1 or K3. What happened? They can form the neighborship now. What happened if I'm going to disable this guy? I said, okay, you're going to use the K4 now, not the K3. They will not form the neighborship. And you will get the syslog message mismatch of the K values. Have a look, go to router 2. And if you see right now, I'm able to form the neighborship. Can you see? I do have a neighborship. What I can do right now, I'm just going to the router EIGRP. I'm going to change the key values. Define the toss always should be 0 because we are going to use the DSCP value. I'll let you know what is DSCP in the quality of service, the advanced classes. So it always should be 0, right? Always. And then you want K1 is what? I want to use this guy. K2 is what? I don't want to use. K3, that's a delay. I want to not use. K4, I want to use. K5, that's empty. I want to not use. What happened? Neighborship has gone. And what masses I'm getting over there? Key value mismatch, and just because of the key value mismatch, my neighbor has down now. So this guy is going to use the K1 or K3. This guy is going to use the K1 or K4. That is the bandwidth, and this is the delay, and this is going to use the bandwidth, and this guy is with the, hey, I'm going to use the reliability, not the delay, not matching. Cool. Next one. So now these two things is good. What happened? Right now, both router is having a ACE number 1 and ACE number 1. They can form the neighborship. What happened if I'm going to configure the 2 over there? They can't. So let's do one thing. Let me correct the mismatch key values. I'm going to, going to make a default. So just remove this guy and have a look at that. Now no router EIGRP number 1. And you see that they have formed the neighborship. Now I'm going to tell this person, hey, you're going to use the ACE number 2 now. Will I form the neighborship? No. See, if you have a look, debug EIGRP packets, and if you go on R2, debug EIGRP packet. This guy is sending the EIGRP hello packet from this guy, right? This sending the hello packet, and this guy also sending the hello packet, but they cannot understand the hello packet because this guy is sending the hello packet with the ACE number 1, and this guy is sending the hello packet with the ACE number 2. No, this guy is sending the ACE number 2, and this guy is sending with the ACE number 1. And you see, I'm always sending. R1 is sending, even R2 is also sending. Someone mic is on. R1 is sending, and R2 is also sending. I'm not exchanging, right? Listen, I'm not exchanging. Exchanging is what? I will send it and I will receive it. That's the meaning of exchange. I'm not exchanging. I'm just sending. This guy is sending with the ACE number 2. This guy is sending the ACE number 1. They are belong to the different domain. What I told you yesterday. ACE number is a logical group of router, right? This is the logical group. Between this two logical group, no communication will happen by default. We'll see some scenario. I will provide the communication, but by default, they don't have a communications. They will not form the neighborship. So they must belong to the same subnet. So not same subnet, same ACE number. So the two router, right? If the router number 1 They can't form neighborship. So they must belong to the same ACE number. What is the next thing? Let's do on a router number 1, and I'm going to allow, take example, I'm going to make this guy no router EIGRP number 2, and you know, I'm going to call this guy router EIGRP number 1, network 0.0.0.0.0. Now they will form the neighborship. Can you see? They will send it and receive it. Because now these two guys are running with the same logical domain. That's the ACE number 1. And now I do have an ability, you know, to send and receive EIGRP hello packet, sending and receiving. That's the meaning of exchanging. Clear? Now, next one is what? What I told you that EIGRP router ID, if I'm going to configure the router ID of this guy is 101, and if I'm going to configure the router ID, EIGRP router ID, they can form the neighborship. See, do show IP, EIGRP topology. What's the router ID of this guy? R2, 101. And what's the router ID of this guy? 101. So guys, sometimes this kind of question, like, you know, the question they will ask you in the interview, right? Like a scenario based question. Hey, will they form the neighborship or not? Of course, buddy, they can form the neighborship. They don't have an issue with the neighborship. Clear? Now, then, so if the router ID is same, right? You know, I'll write on this part. If the router ID is same, they can. Because the router ID is not exchanging in your hello packet. Like OSPF, they can't form that. Like in OSPF, they are exchanging the hello packet in the router ID in the hello packet. But in, you know, EIGRP, they are not exchanging. I'll let you know whatever the issue is happening later on, not now, but they can form. What is the next thing? Right now, they have a neighborship, right? I'll just go on a router 1. I see that 100 permit, not permit, deny any. See what happened? I blocked the EIGRP in ACL and I call that ACL into the interface. So what happened? He is trying to send the, see, if you go back to the router number 2 and put the command debug EIGRP, right, packets. And if you go back to the router number 1 as well as debug EIGRP packets, on this particular interface, what I call this guy, and this guy name is ACL, and this ACL is denying, hey, if this EIGRP is coming in your network, block it. So I'm sending, am I receiving? I'm sending the hello, hey, I want to form the neighborship with you. R2 is also sending, right? Can you see? Sending. But they are not receiving. But when R1 is sending this hello packet, R2 is receiving. You see, receive hello from the neighbor, 101. Receive hello, right? But what of the R1 now? R1 is just sending, not receiving. So if I cannot exchange, it's a unidirectional. It's like a unidirectional. If I cannot exchange the hello packet, I will not form the neighborship, right? All good. So make sure that in the ACL, access list or that EIGRP should be allowed.
No, man.
Don't enable the debug in the production interval, guys, and not even in the examinations. It's hitting the CPU. Now they will form the neighborship. See, do swipe EIGRP neighbor because I received the hello. Cool. Next part. So just me write down this part. If ACL is configured, okay. If ACL is configured, sir ACL extended the full service block हो जाती है ना? हाँ. Next part. So right now they do have a neighborship between this person and this person, right? What I can do now? Yeah. Passive interface. By default, after enabling the EIGRP on this particular interface, right? After enabling the EIGRP on this particular interface, what happened? This interface is behave like active, right? After enabling the EIGRP on this particular interface, this interface will become the active. Active is what? I can send and receive hello. But after making a passive is what? Stop sending and receiving. So if I'm not going to send and receive, will they form the neighborship? What is protocol 88 in the ACL? I don't know how it. This is the basic thing, Namit, that you must need to know. What is the protocol number of EIGRP? What is the protocol number of EIGRP? 88 that I've called over there. Get it? Understand? If you acknowledge me, then I can proceed the next part. If you don't acknowledge, how can I proceed? Understood or not? No, seriously, this kind of behavior, I don't want like from many people because I don't have a extra time to talk about this silly things. Like, I'm asking to you and you're not responding. I hate this part. Okay, so the active, right? So by default, the EIGRP interface move in the active one. Once I'm going to make this as a passive, what happened? Am I exchanging the packets over there? Can you see my debug is enabling, right? And if you go back to the R2, debug EIGRP packets, can you see R2, right, is sending the hello packet. Will R1 understand? No, because this interface is passive. Passive means it's blocked. So will I form the neighborship? No. So if the interface is passive, right? If you see show IP protocol, what this guy is telling you, it's not showing over there. Yeah. This interface is passive. If the interface is passive, they can't form the neighborship. All clear? Guys, if you don't know the passive, let me know whatever things you don't know. I'm assuming you know this part because this is the part of CCNA. If you don't know, let me know. I can teach you, right? If you don't know, if you know, it's fine. So if you're not giving me like acknowledge, I am assuming you know this part. Khatarnak, bhai. Khatarnak. Don't know law. So then why didn't you tell me this thing you don't know? R1, R2, switch. Guys, I'm assuming this part is a basic CCNA, right? So you must need to know this part. If you don't know whatever things, let me know. I can help you out. If you're not going to tell me, I'm assuming, okay, you know this part. This is the 192.168.12.0 subnet. Okay. And this is the 192.168.1.0/24. This is the 192.168.1.0/24. Now, normally your EIGRP packets is sizes. If I'm going to talk about the EIGRP packet size, hello packet, near around 80 to 90 bytes, right? Near around. Now, and your EIGRP is what? It's a layer 3 protocol, right? So your hello packet also will be what? Layer 3. And this interface, this switch is what? It's behave like a layer 2, right? Now, tell me one thing. If I'm going to enable the EIGRP, right? If I'm going to enable the EIGRP on this particular interface, what happened? They will form the neighborship. And they will form the adjacency as well as a logical connection. And after that, what happened? They can exchange the route. You will say that, hey, I have something for you. That is, this guy. I'm going to share that about my own information, 192.168.1.0/24. Same thing, what happened? Now, this person will tell, hey, I have something for you. That is, now. So after enabling the EIGRP on this particular interface, they can form the neighborship and they can form the adjacency. And after that, what happened? They will exchange the route. And now the R1 will maintain this information in the routing table 2.0 information. And R2 will maintain the 1.0 information from the in routing table. And now they can communicate to each other. Now we do have a communication between these two pieces. This is good, right? The EIGRP what is the use of network statement? Enable the EIGRP into the, enable the interface into the EIGRP. Now tell me, I also use network statement for this particular person, right? I also used network statement for this particular person. Why am I use the network statement for this particular person? So that this interface is now enabling the EIGRP. And so that now this interface will be enabling the EIGRP. And I can exchange this information to the neighbor router and they can exchange the information to me. That's why we have enabled the EIGRP on this particular interface. But that's good, right? You have enabled it. But after that, the router one keeps sending the hello packet from this interface, keep sending at every 5 seconds. And in this hello packet, what information I'm going to put? Take example, the IP of this interface is 1.100, and so MAC address is A. So the source MAC address will be A, destination MAC address will be what? Multicast MAC address of EIGRP. Source protocol number, sorry, type field 0x0800, IP. Layer 3 information, 1.100 will be source IP address, right? Destination will be what? .10. A layer 3 packet, EIGRP 88. And if you have a 12.0 IS version, in the 12.0 IS version, you will have a TTL field 2. And if you have a 15.0 IS version, you have a TTL field 1. I'll show you this part, don't worry about that. Just for the intro, right? So take example, I'm going to use the 12.0 IS version on the router. So it should be TTL 2. And this information, the size of this packet is what? 80 to 90 bytes. Guys, tell me, what is the use of this packet? To form the neighborship and to maintain the neighborship. Now, R1 will keep sending the hello packet from this interface, right? Tell me, will they understand this packet switch? No. Will they understand this packet? No. What they will do? They will just drop it. So why R1 is sending this packet to this guy, right? The LAN network. Why? You are sending on this guy, you are sending on this guy because they are the router. They can understand the hello packet and they can maintain the neighborship. And if you're sending on this particular network, right, the LAN network over there, this guy does not understand the hello packet. This guy does not understand the hello packet. Then why are you sending the hello packet on this particular subnet over there? On the LAN information, you are sending on the WAN, it's good because on the neighbor side, you have a router over there. But on the LAN side, it's not good. This interface is now active, right? Because I have enabled the EIGRP. It's totally wastage of the bandwidth of this particular link and wastage of the resources of this particular switches as well as. So to avoid this problem, what I can do over there, guys, this interface is now active. I can make this guy as a passive. Once I'm going to make this guy as a passive, now it stops sending hello packet. And that's we are doing over there. You can configure the passive interface always in the LAN side network, not the WAN side. So if you see, if I'm going to configure the WAN side, can you see that what happened? My neighborship has dropped because this guy is not extending the hello packet because the interface is what? Passive. You can use this command as well as default. Default means what? All the interface will become the passive, whatever the interface we have. Do so IP protocol. Can you see all the interfaces? For example, I don't want to make this guy as a passive. Take example, what I can call this guy. No passive interface. So now what happened? They can extend the hello packet and they will form the neighborship. Do you all? Do so IP protocol. Now what happened? 0/0 is not a passive except the 0/0. All interface is passive. So take example, if the router 1, this interface is the WAN connection, right? That has a router number 2. So I want this guy should not be a passive, but all the interfaces, all the LAN interfaces, all these are my LAN interface. All this should be a passive. So how many commands I'm going to put? 0/2, 0/3, 0/4, 0/5, 0/6. Make a passive interface default. Make a passive interface default. And after the passive interface default, what happened? All these interfaces, every interface become the passive, and just let no passive interface 0/0. Hey, I don't want to make this guy a passive. Only this guy should be passive. Been I clear now? Okay. So guys, your interface should not be a passive, right? Make sure that this part. So your interface should not be passive. Next part is what? What we have seen. This part we have seen, this part we have seen, this part we have seen, this part we have seen. This interface should not be a passive. Now this part, authentication. That's buddy, right? I don't think so. This thing I need to tell you, right? Authentication, remember, if you see, I can show you. So right now, to show IPHRP neighbor, I do have a neighborship, right? I do have a neighborship. What I can do, I'm just going to apply the authentication on this person. I'm going to set the password CCA, and this guy is no password. So what happened? He will send the hello packet to this guy. They will drop it. Hey, Arun will ask, hey, what's your password? This guy is going to ask, hey, what's your password? Arun will say, I don't have a password. No password. No password. You are the unauthorized person. You are unauthorized person. I will not form the neighborship with you. Let me drop it. So password authentication. What is the role of authentication in EIGRP, guys? To authenticate, right? Rule of authentication in EIGRP. To authenticate the router. Is this a valid router or not? If the router is valid, they have a valid password. If the router is valid, they have a valid password. If the router is not valid, they don't have a valid password. So I have set the password on this particular CCI, and you don't have a password, no password, you are not an authorized person. I'm not going to allow in my domain. If you have a same password, CCI, then I can form the neighborship with you. Otherwise, I will not. And in EIGRP, right, you will have a MD5 authentication. You also have a HMAXA that I'm not going to discuss right now. I'm going to discuss in this topic, named mode, something called as a name mode, right? We'll discuss this part in the name mode. But right now, I'm just discussing the MD5, right? You can set the MD5 password over there. And I'll tell you one thing, it's not recommendation to use the MD5 nowadays. Cisco always recommend don't use MD5 in these days now. It's easy to break. Any attacker can break this one. And again, this is authentication is part of your CCNA. Must need to know this part. How do I enable the authentication? Anyone knows the command? Tell me. Anyone has an idea of the command, how to enable the authentication? Anyone has idea about the how to enable the authentication?
Cisco password
Keychain, right? Keychain. The keychain will be ABC, key ID will be 1, key string will be CCI. This is your password. And I'm going to call this guy on the interface IP authentication. What? Mode will be EIGRP number 1, MD5. I'm going to set. See, I just have MD5. And then IP authentication, what we call over there. Keychain will be what? ABC that I've made.
Plain text
Sorry?
Plain text
Plain text doesn't support by the EIGRP. EIGRP does not support the plain text. So now if you see what happened, you got this message. Hey, auth failure. What failure? Auth failure. Keychain is missing. Auth failure. So router will drop the neighborship just because of this part. Auth failure. And you can also have this message. So if one side is running with the authentication and another side is not running with the authentication, they will drop the neighborship. Done. Now let's do one thing. Let me remove this guy. I'm not interested in this part. Let them form the neighborship. It has to be same on the both side, guys. If it's not same, they can't form the neighborship. Okay. So now they will form the neighborship. Good, right? So you can see I do have a neighborship. Next part. What is the default hello timer and hold on time? 5 and hold on 15, right? Let's do one thing. What I said, this guy is running with hello time. 5 seconds. This guy is running with a hold on time. 15 seconds. What this guy is running? Hello time. 5 seconds and hold on time. 2 seconds. This guy is not going to drop your neighborship. Can you see that? I'm not dropping the neighborship. Pay attention, guys, over there. This is the important. I'm not dropping the neighborship. What I'm doing, I'm flapping the neighborship, flapping up, down, up, down, up, down, bouncing the interface. What happened in this case? User can communicate, but packet loss will be there. User can communicate, but packet loss will be there. User can communicate, but packet loss will be there.
पैकेट लॉस कंटिन्यूअसली चलेगा।
और आप देख रहे हैं अप डाउन हो रहा था, कभी जाएगा कभी नहीं जाएगा, कभी जाएगा कभी नहीं जाएगा, कभी जाएगा कभी नहीं जाएगा।
ऐसा कोई ऐसा टाइम जब बंद हो जाएगी
ना, ऐसे करते ये फॉर्म भी तो कर रहा है। ऐसा है कि ये बंदा इस बंदी से बात कर रहा है और ये बंदी एक बार उठा रही, एक बार नहीं उठा रही, एक बार उठा रही, एक बार नहीं उठा रही, एक बार उठा रही नहीं। तो ऐसा थोड़ी ना कि ये ब्रेकअप डायरेक्ट कर रहा है, नहीं, इज कम्युनिकेटिंग राइट नाउ।
ओके
Done. Now one question they will ask you, like in your like your interview sometimes, like how does a router know that how much, how should or how long I should wait? Listen to me carefully. Sometimes in the interview they will ask you question, how does this router will know that how long I should wait if I'm not receiving the hello packet from my neighbor? एक चीज मैं बता दो, यहाँ पे मैं लिख देता हूँ उसके लिए, यहाँ पे पॉइंट, you know, solve. If hold on time is lesser than hello time, then flapping will happen, right? But in the case of another thing, if you have a one more thing that I want to discuss with you, actually, or hold on, man. Yeah, that's my question. Like, you know, what I'm telling you, like if the router two, like how does this router two will know that how long I should wait if the router one is not sending the hello packet to me based on the hold on time? But how does R2 will know that what's the hold on time of R1? How does R2 will know that what's the hold on time of R1? How does R2 will know that what's the hold on time of R1? Now, because in your hello packet, router is extending the hold on time. TTL2, which version I'm running? 12.4, right? I'll show you in the 15.0 as version tomorrow, not tomorrow, on the Sunday class. I'll show you this one. TTL2 is there, right? In the 12.4 version. Yep. And Cisco EIGRP. And if you see parameters, you will have a key values in the hello packet, right? The EIGRP version 2 we are running. And if you see parameters, we have key 1 is by default, key 3 is by default. Forget key 6 right now. Okay, you know this one. Key 1 is by default and key 3 is by default, and hold on time over there. So in the EIGRP hello packet, we are seeing the hold on time, right? So based on this guy, they will know that, okay, what's the hold on time of EIGRP and how should I wait? And over hold on time, I'm setting 25. So R1 is right now, is running the hold on time is what? 25 seconds. And this guy is running with the hold on time is what? 15 seconds. They can form the neighborship. See, I do have a neighborship. I do have a neighborship. I do have a neighborship between these two guys because they have a different hold on time. They have a neighborship. So you can write one more thing. I forget to tell you about this part. I have to tell you. Okay. So if router has, or if EIGRP router has mismatch of hold on and hello time, they will form a neighborship, but not in also. Yep. That's why it's not recommendation to the change the timer. I'll just let you know, if sometimes they're asking the question in the interview, right? They will give the scenario, okay, router 1, router 2, and tell me they are running those swap and they are different timers. So person say, okay, they will not form the neighborship. What happened if I'm going to configure the EIGRP? The same answer they are giving. They will not form the neighborship. They can form the neighborship. But the timing is mismatched. Due to that, what happened? It has to wait for the 15 second. It has to wait for the 25 second. That's an unstable network, we can call it, right? Now, guys, here I'm done with the hello packet. Mera hello packet यहाँ पे खत्म हो गया. So hope this hello packet is clear to all of you. All this thing is happening. All this thing is happening just because of hello. So my hello is clear. So hello is set on the dot 10, and can be sent on the unicast as well as, okay, if you're going to form the unicast neighborhood, that we'll see that later on. But yeah, it can send the unicast and multicast as well as. Something is all there. I cannot say that completely I have done with the hello packet. Yes, I'm done with your 80%. 20% still remain. That this 20% you will get to know that during the the key values. Anyone has a questions in the hello packet, now you can ask me. One task that you have to find, how to check what is the command to check hello time in EIGRP. Tell me the command. Hello and hold on both. What is the command to check the hello time and hold on in EIGRP? You have to find the answer of this question.
नेक्स्ट क्लास में बताना.
अभी बता दो, बता दो.
अभी तो नहीं पता.
तो मुझे पता था. Anyone else? Anyone knows that what is the command to check the hello time in hello time in EIGRP? निजाम तुझे पता है? ऐसा कोई कमांड ही नहीं है. So IP EIGRP timers, that will show you the timers. So IP EIGRP timers, ऐसा तो कोई कमांड ही नहीं.
देखा, मुझे पता था.
क्या
कमांड नहीं है इसकी.
क्या बोला?
मैं सर मुझे पता है कमांड नहीं है इसकी कोई.
है तो कमांड दिखा तो रहा स्टेटस. ये है कुछ भी. So IP EIGRP स्टेटस में क्या दिखाता है?
ऐसा तो नहीं है कि जैसे ये कमांड्स ये पे चलती है और जीएनएस में नहीं.
ऐसा कुछ नहीं होता है. So IP इंटरफेस नो ठीक है। यहाँ से तुमको पता चलेगा क्या क्या चीज, दो चीज पता चलेगा कि तुम्हारा ऑथेंटिकेशन मोड कौन सा सेट है एंड मैं क्या यूज कर रहा हूँ। होल्ड ऑन, तुमको वहां से पता चलेगा निवेश। Okay, guys. So here I'm done. See you on the Sunday class, 2 p.m.
चलो वो HSRP का